Hello to all of you and welcome back to my SB2 channel. This video is all about titration. We're going to be looking at the introduction for titration, a little bit on the titration procedure. We also have a stoichiometry calculation for titration, and I also have a practice for you at the end. So to introduce titration, you can think about it as a very classical lab techniques that we use to determine the concentration of an unknown solution by typically reacting it with a solution of known concentration. This method allows us to accurately measure the unknown concentration, make it very important and essential tool in our research, in our medicine, as well as many of our industrial procedures. There are a few things that we have to kind of introduce them in terms of the vocabulary. For titrant, that's a solution of known concentration that is added to the unknown solution, right, during the process of titration. And sometimes they call that the standard. The equivalence point, it's the point that at which the moles of the titrant added are exactly equal to the moles of our substance being analyzed, which is the unknown, right? And that means the reaction is being completed here. We also have indicators. I'll talk about the importance of that, which is a substance, typically an organic compound, that colors of that compound are depending on the structure of that, and it's going to have a color change at or near the equivalence point to signal the completion of the reaction. So this is going to be our titration procedure. You can imagine if you want to do in the lab, these are going to be your pieces of glassware. So you're going to grab a flask and you're going to add exactly, let's say 20 milliliter of your sample, right? So you have to be careful with the volume here. That has to be pretty accurate. And in this case, I have an unknown acid. So we'll try to figure out the concentration for this acid, okay? Now I'm going to add a few drops of my indicator, and the indicator's idea here is because most of the acids and bases are colorless, we typically need to have a kind of help to navigate through the procedures. So for example, if I add an indicator here, the color change is going to help me where we are, right? So just a few drops of my indicator here. And then I'm going to grab my burette. You're going to add your standard. In this case, I have sodium hydroxide. And you know exactly your, volume of your standard, right? And then you're going to start adding your standard to your solution very slowly, right? Until you see the color change. So as soon as you got the color change, you're going to stop adding more of your titrant, right? And that point is going to be our equivalence point, where we know that all of our acid has been reacted with our titrant. So now let's take a look at how we can do the stoichiometry calculations for these reactions. So typically, you probably remember from our previous lectures, typically these procedures are a little bit challenging, and we try to really break them down into smaller steps, right? And we can follow the steps, and hopefully that would make the whole procedure a lot more easier to understand, right? So here is the first thing. You got the volume of your standard solution from your burette reading, right? Now you're going to go from the volume to your moles of your standard solution. So how do we go from volume to the moles? Think about it for a moment. Yeah, exactly. We need to use the molarity or the concentration of our standard solution, which is something that we already know that, right? Okay, cool. So you've got the moles of your solute. Now you want to use that in order to get to the moles of another compound, which is going to be your unknown solution here. So how do we go from moles of one compound to another one? Yes, you are right. We need to use the coefficient in our balanced equation. Okay, so at this step, we got the moles of the solute, right, for our unknown solution. If you try to figure out the concentration, right, which is pretty much the goal, right, for this experiment, we just need to use the volume of our unknown solution to do that. Okay. Okay, I hope that makes sense. So I'm going to show you a practice, right, using all of these steps on the next slide. So take a look at this practice. It says one commercial method used to peel potatoes involves soaking them in sodium hydroxide solution for a short time and then following by kind of a spraying of the peel. the sodium hydroxide concentration can range from 3 to 6. Okay, then we have one analysis. It says we have 45.7 milliliter of 0.5 mole per liter of sulfuric acid, which is required to neutralize 20 ml of sodium hydroxide solution. What is the concentration of sodium hydroxide? So we're looking for the concentration of sodium hydroxide. Okay, so starting by calculating moles of sulfuric acid. The only thing here is the volume that is given is actually in milliliter. So I need to convert that to liter, right? And I know every thousands milliliter is going to give me 1 liter. So I can cancel out the milliliters here. All I have at the moment is liter of my sulfuric acid solution, right? Okay, then I need to use the concentration as it given on the question stem, right? And I can cancel out the liters. So all I have at the end is the number of moles of sulfuric acid. Okay, so if I want to go from moles of one compound to another one, I need to use my chemical reaction, right? So this is an acid-base reaction. So I know that I'm going to form water and my salt, which is sodium sulfate. Make sure you balance your reaction, right? Now, the next step is using moles of sulfuric acid to calculate the moles of sodium hydroxide, right? So look at your reaction. 1 mole of sulfuric acid reacting with 2 moles of sodium hydroxide. So you set up your stoichiometry coefficient here. You can cancel out the moles of sulfuric acid, right? So what I have at the end is the number of moles of my sodium hydroxide. Okay, so I've got the moles. All I need to do is I need to convert that to the concentration. And remember, by definition, your molarity is going to be mole per liter. You've got the moles. You just need to divide that by the liter, and it was 20 ml given by the question stem. And make sure that you convert that to your liter, right? So every thousands milliliter would be 1 liter. You can cancel out your units, and all I have at the end is the number of moles of sodium hydroxide over the liter, which is exactly what we called molarity, right? That's my concentration. Thank you so much for watching this video. If you found it helpful, don't forget to give it a thumbs up, and you can also share that with your friends. If you're enjoying the content and you want to keep learning with me, all you need to do is hit the subscribe button, right? If there's anything that you want me to cover that for you, you can definitely email me or you can leave a comment below. Thank you so much, and I'll see you soon. And by the way, this video was the last video of this chapter. I'll see you on the next chapter soon. Bye bye for now.